Hi, and welcome to my lecture on the alternating series test. Okay. So the alternating series, it has a very simple form, and it's for series that involve, we'll start this at 1 and go to infinity, a minus 1 to the n power. Okay. And they're being multiplied by this series b sub n. Okay. So this is the form of an alternating series. And this is where b sub n is a positive term because we've already accounted for the alternating negative part. So for n equals 1, this is negative. For n equals 2, this is positive, etc. So for example, if I was to write out these terms, the first term is going to be a negative b sub 1. The second one is going to be a positive b sub 2. Then it's going to be a negative. Then it's going to be a positive, etc. Okay. Okay, so the alternating series test says this. It says that the series converges, and the series being this thing, if two conditions are met. And these two conditions are, first, that b sub n is decreasing. So the okay, and two, that the limit as n goes to infinity of b sub n is equal to 0. Okay, and let's start off with our example here. And this alternating series, anytime you see a minus 1 to the n power, you might consider using this alternating series. Okay, so here's going to be an example. Is this series is it convergent or divergent? Okay, and we'll answer this using the alternating series test. Okay, so okay, and here b sub n, it's everything excluding the minus 1 to the nth power. So this will be 1 over n. Okay, so the first thing that we're going to check is that b sub n, which is 1 over n, is bigger than or equal to b of n plus 1, which would be 1 over n plus 1. Well, that's true. Okay, n has to be an integer starting at 1 or bigger, so this is always true for those values. Okay. The second one says that this limit as n goes to infinity of b sub n, well, that's just this limit as n goes to infinity of 1 over n, that's equal to 0. So those two things are true, and that means, since these two things are true, that the series is convergent. And we just need to check these two things. But these two things only apply for alternating series. Okay. Okay. Now I want to give you another definition, and this comes later, this concept, but it's this idea of absolute convergence. So this summation of minus 1 to the n times b sub n from n equals 1 to infinity is called absolutely convergent. If the summation from n equals 1 to infinity of the absolute value of the term, so that way we take away the negative symbol, okay, so the absolute value would just be b sub n, if this is convergent. Okay. Otherwise, the series is called conditionally convergent. That is, if it converges, but it needs that alternating part. Okay. So let's do an example of this, and let me note one thing. Note if the summation from n equals 1 to infinity of b sub n is convergent or absolutely convergent, then the summation from n equals 1 to infinity of minus 1 to the n multiplied by b sub n is also convergent. And this is by either the limit comparison or the comparison test. Okay, let me give you two examples here. And the example I'm going to consider is the one we just had with minus 1 to the n divided by n. And this is not absolutely convergent. Okay. And this is because if I take away the minus sign and I put absolute values around everything, this summation is going to be the sum from n equals 1 to infinity of 1 over n. And 1 over n, it's a divergent p-series, or you can use the integral test to show that this is divergent, as I've done in previous videos. Okay. This is a divergent, and I'm going to say by the p-series with p equal to 1, or by the integral test. And so our conclusion is this series from n equals 1 to infinity of minus 1 to the n over n is called conditionally convergent because because it doesn't converge without the minus without the minus 1 to the n. It absolutely needs it. Okay. Here's going to be an example of one. That is absolutely convergent. Because if I take the absolute value of these terms, I get minus 1 to the n absolute value over n squared, and this is just the series from n equals 1 to infinity of 1 over n squared. And this is convergent by a p-series with p equal to 2, or the integral test. Hence, we know, since we know that it converges without the absolute value, since it converges with the absolute value, we know that it converges also without it. Because if it converges without the alternating part, then the alternating part also converges. So hence, minus 1 to the n over n squared is absolutely convergent. Okay. Now, there's one more thing that I like to talk about for the alternating series, and this only applies for alternating series. Okay. And this is an estimation. So this is the alternating series estimation theorem. Okay. And it says if this alternating series of minus 1 to the n multiplied by b sub n satisfies these two conditions, one, that it's decreasing, so just the premise of the alternating series test, but this one's on estimation, and also that the limit is a limit as n goes to infinity of b sub n is 0, and this one isn't really listed in the book, but the terms of b sub n are positive. The only negative part is that minus 1 to the n. Then we are going to have that the remainder r sub n, which is this summation, is the absolute value of this summation. And let me back up for a second there. The technical definition of the remainder of r sub n is going to be s minus s sub n. And if we write this out, this is the absolute value of the sum from n equals n plus 1 to infinity of minus 1 to the n multiplied by b sub n. And that the theorem is that this is less than or equal to b of n plus 1. So if you're asked this question, so by the way, this is the alternating series estimation theorem, put in a box, and you're asked this question, how well does the first 10 terms, n equals 1 to 10, of minus 1 to the n over n, estimate the value of the series well, we'd answer this with the alternating series estimation theorem. And this says that this summation, that the remainder, everything else, so this summation from n equals 1 to 10 of minus 1 to the n over n plus the series from n equals 11 to infinity of minus 1 to the n over n. Well, that this term right here, okay, so this is less than or equal to the summation from n equals 1 to 10 of minus 1 let me explain this another way. Okay. So this term, summation from n equals 11 to infinity of minus 1 to the n over n, by the alternating series estimation in absolute value, this is less than or equal to b of, well, 11, and b of 11 is going to be 1/11. And so this is how well the full series would be these two terms, but if we just had only this first part, it would be accurate to within 1/11. So the first 10 terms are accurate to within 1/11 of the full answer, and the full answer is what you get when you add both. So the answer is, it is accurate. So my apologies here, getting a little sloppy. Okay, and that's all that we have for today. Thank you for joining. The two take-home things, well, three, but the most important, I'm going to go by order of importance. Most important thing that I want you to take away is this alternating series test. It lets you test for convergence or divergence of a series. So if a question asks, is the series convergent or divergent, you can just answer it using this alternating series test. A second idea is this idea of absolute convergence. So if you're asked, is your series absolutely convergent, you have to take the absolute value, so take away the alternating part, that minus 1 to the n, and determine if the series of just positive terms is convergent. If it converges, then you know that the alternating series converges. But if it diverges, it doesn't tell you anything as to if your original series converges or diverges. So then you have to go back and you have to use the alternating series test. If it converges with the alternating series test, but not absolutely, it's called conditionally convergent. Okay. Then the last idea is some sometimes you'll be asked, how accurate are these many terms of the series as an approximation to all infinity of them? And you can use this alternating series estimation theorem to answer that question, as long as it's an alternating series that meets conditions 1 through 3. Okay, thank you very much.